Certain infectious microorganisms can cause outbreaks that can be extremely devastating. Let's examine the etiology of these outbreaks. Typically, emerging and re-emerging microorganisms are responsible for these outbreaks. However, not all of them are zoonotic. Welcome to the Infectious World channel, where we discuss various topics related to public health and microbiology. Today, our focus will be on the emerging and re-emerging infectious diseases. Emerging infectious diseases are classified into three categories. The first category is rare and refers to illnesses that have never occurred in humans before. The second category includes diseases that have affected small populations in isolated areas in the past. The third category comprises diseases that have been present throughout human history but have only recently been recognized as distinct illnesses due to an infectious agent. Re-emerging infectious diseases, on the other hand, are diseases that were previously major health concerns worldwide or in specific countries, but decreased substantially, are now resurfacing and affecting a significant portion of the population. Malaria, tuberculosis, cholera, and pertussis are prime examples of re-emerging infectious diseases. Various factors contribute to the emergence and transmission of infectious diseases, including the ability of pathogens to evolve and adapt to their surroundings. Such factors include the growth of human populations, population aging, urbanization, globalization, climate change, poverty, social inequality, conflicts, migration, wildlife trade and consumption, industrial livestock production, irrational use of antimicrobials, and the development of resistance in both humans and livestock. Let us now look at how population growth contributes to emergence of disease. The rapid increase in population puts pressure on natural resources such as land, water, ecosystems, and services. As the population expands, so does the demand for land, which often leads to deforestation and habitat destruction. Subsequently, this can result in a loss of biodiversity and upset the balance of ecosystems. Soil degradation and water scarcity are additional consequences of overpopulation. Changes in biodiversity can have a significant impact on the risk of infectious disease exposure in plants and animals, including humans. This is due to the fact that infectious diseases require interactions between species. At the very least, these interactions involve a host and a pathogen. However, multiple species are often involved, including additional hosts, vectors, and other organisms. Studies have shown that low diversity in bird and mammal communities can result in a higher risk of West Nile virus and hantavirus pulmonary syndrome, respectively, for humans. This is because communities with limited avian diversity often experience high infection rates in both mosquitoes and people. Undoubtedly, the impact of deforestation on climate change cannot be ignored. Trees are a crucial element in the fight against climate change. By absorbing carbon dioxide, they prevent it from accumulating in the atmosphere. This process is vital in reducing greenhouse gases, which ultimately helps to mitigate the effects of global warming. Global warming has a major impact on vector-borne infectious diseases, but the effects vary depending on the type of vector. The distribution and behavior of vectors are affected, with mosquito-borne illnesses such as malaria, dengue fever, Japanese encephalitis, JE, and tick-borne encephalitis being among the most frequently affected. Impact of climate change on disease outbreaks. The most common diseases that are exacerbated by climate change involve vector-borne transmission, such as those transmitted by mosquitoes, bats, or rodents. Upon examining the type of climate hazards, the majority of diseases were linked to atmospheric warming, heavy precipitation, and flooding. Climate-related risks have brought dangerous pathogens in close proximity to humans. These hazards are causing a shift in the range of animals and organisms that can act as vectors for these diseases. For instance, changes in precipitation and warming temperatures can alter the distribution of mosquitoes, which are vectors for numerous human pathogenic diseases. These climatic hazards have been linked to geographical shifts in outbreaks of mosquito-borne diseases such as malaria and dengue. Now, let us examine the impact of globalization on the emergence of diseases. International travelers not only pose a risk themselves in spreading infectious diseases, but the airplanes they travel in and the cargo they bring along may also act as potential sources of vector introduction. Vectors, such as disease-carrying mosquitoes, can be unintentionally introduced to new areas through transportation means like airplanes and used car tires. Studies have shown that disease vectors can survive in the wheel wells of jet aircraft during long intercontinental flights. Used car tires transported for retreading or other purposes can also carry mosquitoes, such as the Asian tiger mosquito that carries the dengue virus. The impact of wildlife trade on disease emergence. Wildlife trade provides a mechanism for disease transmission of disease to humans as well as animals. Recent zoonotic outbreaks of emerging infectious diseases have been linked to wildlife. These include influenza H5N1, SARS, Ebola, Marburg, as well as MERS. Poverty and infectious disease emergence seem to be linked. When people are poor and are residing in rural areas, they tend to migrate to urban areas in search of a better life. However, this has unintended consequences because overpopulation results, slums also overgrow. Deforestation may occur because of shortage of land, which results in global warming. This creates fertile ground for disease emergence. The reemergence of tuberculosis has been linked to the evolution of the TB bacillus. The bacterium has become resistant to antibiotics, allowing it to proliferate. For quite some time, TB has been a treatable disease. However, with the emergence of multi-drug-resistant TB, as well as extensively drug-resistant TB, it has become difficult to treat patients who are infected with these strains. TB is not the only microorganism that has reemerged as a formidable pathogen due to drug resistance. The malaria parasite has also developed drug resistance to a number of drugs, and with the current artemisinin combination drugs, reports of resistant strains have been reported. Diphtheria has also reemerged. Outbreaks of diphtheria have been reported in recent times. In the case of diphtheria, reemergence is as a result of inadequate vaccination. As previously mentioned, not all emerging infectious diseases and reemerging infectious diseases are zoonoses. Infections due to vancomycin-resistant Staphylococcus aureus and Candida auris, which are multidrug resistant, are also referred to as emerging infections due to multidrug resistance. Lyme disease caused by Borrelia burgdorferi, hantavirus pulmonary syndrome caused by hantavirus, as well as Lassa fever are emerging diseases. They emerged when humans encountered the respective vectors in higher numbers. The insect vector in the case of Lyme disease, the rodent host in the case of hantavirus pulmonary syndrome and Lassa fever. The emergence of infectious diseases such as Legionnaire's disease and hemolytic uremic syndrome is related to air conditioning systems and mass food production, respectively. As always, thank you for watching. If you have enjoyed this video, please don't forget to like and subscribe.